Good morning, everybody, and thank you for being here for season 2 of the Building Performance Interactive series. My name is Zach Stemke. I am with Passive House Accelerator, and I'm super excited for today's program. Before we dive into the program today, I want to just explain a little bit about the role that I will play, which is as Q&A concierge. So as questions occur to you during today's presentations, please type them into chat, and we'll be tracking those questions. And when the discussion session time comes up later in the program, we'll invite you to ask your question directly of the presenters. So I want to also thank Partel for collaborating with Passive House Accelerator on this series and creating the series last year. It's very exciting to be re-upping it in 2023. We will be joined today by co-hosts Hugh Whiriskey and Ben Adam Smith, and they will be helping to keep the conversation flowing today. We'll be joined by guest presenters Pat Kirwan and Brian Kennedy, who will talk about offsite construction meeting growing demand for better buildings. So with that, I'll hand it off.
Yeah, hi, I'm Ben Adam Smith from House Planning Help website, and we're a website that focuses just on housing, trying to make it better. Also, if you've got an existing property, what it might look like to make it healthier, more energy efficient, and how you might go about that. So yeah, it's great to be back. We've done the first season, so season 2. I think Mike is not with us this time, but we're hoping he'll be back in the next session. But Hugh's here. Hi, Hugh.
Thanks, Ben. Yeah, thanks, everyone. I guess my name's Hugh Whiriskey. I represent Partel. We're a materials provider for the built environment, so membranes, tape, sealants to, I suppose, to lots of the modular construction companies, and we operate in the UK, in Ireland, North America. But today, thanks to the Accelerator for the collaboration again, to all the guests for joining, and our, I suppose, our presenters here. So today I'd kind of, I suppose, really like to introduce Pat Kirwan. Pat Kirwan is a director and the head of modern methods of construction at C&W O'Brien Architects. Pat has been I suppose, a driving force in the industry for the last number of decades. He's an early advocate for sustainability in the industry and was actually one of the founding members of the Irish Green Building Council, who have consistently pushed and helped to I suppose, make targets for lower carbon, more mainstream, and yeah, having a real impact. I suppose Pat has worked on many high-profile projects, the redevelopment of Spencer Dock, the Aviva Stadium, the Central Bank in the Docklands. He's also implemented BIM strategies on large-scale projects. I first met you, Pat, I think in 2012 on a WFI course, and yeah, you're someone I know to be, I suppose, an innovator with a skill set that goes kind of all the way from sustainability to compliance to building physics. So kind of the ideal person to take us all through MMC and what it means today. So over to you, Pat.
Hi all, thanks for the introduction, Hugh. Very flattering. I think those days in 2012, I think certainly a long time ago, sitting down, working our way through the WFI software. So I think we've come a long way since then as an industry. I guess today, this afternoon for us here in Dublin, probably early morning for most of the participants. But today I'm going to talk about modern methods of construction and how do we transition between lean and green construction. So implementing sustainability strategies through modern methods of construction, using lean design and lean construction methods to achieve sustainability goals. I think it's always good to remind ourselves, why are we doing this? Why do we need to really embrace a more sustainable, low carbon built environment, and particularly a construction industry? The latest report from the IPCC really identifies a critical need to tackle global emissions in order to reduce the impact of global warming, particularly as we perhaps begin to look at exceeding 1.5 degrees Celsius. And again, just a brief summary from the latest IPCC report, just kind of captures we're absolutely at a critical path. We're at a crossroads where we've already missed certain opportunities to really embrace and tackle climate change. And we're now at the critical juncture of we need to start actioning, we need to stop talking and actually doing. And yet, as you can see here, in terms of the present situation, we can really drive on in terms of tackling the impacts, or we can carry on with not business as usual and end up with significant issues in terms of that global warming impact. I think we always generally, I think we see in life, I think we say, you know, issues, it doesn't really affect us. It's someplace else. You know, that's in another part of the world. It's not really impacting here. I don't really see the change. This particular slide shows the average air temperature over a period in Ireland, Ireland being a small country. So you can see in terms of 1900 all the way up to 2019, there's a significant difference in terms of the surface air temperature, the rising of that temperature. So it is a global problem. It is affecting every single country, every single part of the world. So we do need to really begin to action those issues. And how do we action that? You know, in terms of we're all here, we're all involved in the built environment. The built environment, according to the World Green Building Council, contributes approximately 39% of global emissions, carbon emissions annually. That's a significant impact when you look at, you know, the physical act of construction. So it's really, you know, imperative that those actors, that those participants within the construction industry really build the knowledge and start actioning on that. And if we look at that 39%, you can see the breakdown: 28% in terms of operational carbon and 11% in relation to embodied carbon. I think we're beginning to look at the operational carbon, the likes of passive house methodology, fabric first approach, you know, reducing the impact, really new innovative technologies in terms of low carbon technologies, etc. But also actually all of those new technologies, all of those new methods that we're deriving out to reduce the operational carbon also have an embodied carbon impact. So we need to start looking at a holistic approach to carbon, not just the operational carbon, but right through the process, and from the materials, from all aspects. And how do we do that? Again, referring back to the World Green Building Council, a chart, the absolutely optimum time to do this is at early strategic stage in terms of any project. Our planning, obviously, to reduce the impact, we build nothing. We can't do that. We're growing global population. We need to start building more. We need to start building infrastructure and critical facilities such as hospitals, schools, etc. So we need to look at that. The next impact, the next opportunity, we perhaps build less. So we need to look at using existing assets, deep energy retrofitting. How do we impact that? So then referring that back to modern methods of construction, how do we take modern methods in construction in terms of a deep energy retrofit and look at the carbon impacts of that? And obviously then we need to build clever and build efficiency, but we need to tackle that at the early design stages, at the strategic stages. And what does that impact? And I guess this graph or this graphic really shows the impact of that at design stage. In my view, I think the design phase is the critical point, because at the design phase, we're designing the building, we're identifying how it's going to be built, and perhaps the construction methodologies, which then has a direct relationship on the natural resources, the raw materials, how the raw materials are made. Then going forward into the production and the manufacturing process, you know, again, the construction methodologies that we define out to build the asset that we've designed, you know, will have a direct impact on the production and how we design. Are we designing for reuse, readaptability at the end of the life cycle of the asset, and then how do we recycle the asset at the end? So it's a circular economy. It's that circular process, which again, in my view, starts at the design stage, and it's critical that we start as designers within the built environment, that we build the knowledge and start addressing that. In terms of the physical act of construction, the physical act of design, we can look to other industries such as the automotive industry in relation to more efficient, more optimization. And this is where we kind of start to look at modern methods of construction, prefabrication, etc. And again, looking at a lean approach. These are the 5 principles of lean. Identify the customer value, specify the customer value, identify and map the value stream, create flow, respond to customer pull, and perceive perfection. But if we start overlaying an environmental approach to that, so these are the main principles of lean thinking, and it can be applied to lean construction. But if we apply an environmental aspect onto that, so again, identify customer value. So what are the environmental goals of a project, of a built asset? Identify and map the value stream, develop up a roadmap, bring that into the design phase. How do we integrate that? What is a plan of work for integration of sustainability right through the entire life cycle of the asset? Obviously, create flow by eliminating waste. We have many wastes, and I'll come to that in a second. And then respond to customer pull. So again, we can respond to the ongoing environmental changes that might be occurring, and be it legislative or climate change. We can then respond and recycle, review that process. Perceive perfection, something that we don't really tackle within the built environment. Research, innovation, research and development. As built audits, how are our built assets performing, and feed that back into that loop. I spoke about the waste again, the 7 wastes of MUDA, which would be defined out by the Toyota production system. And again, we can apply these. These are wastes that would have been identified to, say for example, the Toyota production system. But we can to look at these in the context of the environmental aspects. Inventory could be applied to the raw materials. So if we start reducing the impact on the raw materials, we're reducing that waste, etc. Defects. Again, defects in terms of construction methodologies. If we apply that to prefabrication, offsite construction, and we say, we're prefabricating elements where we get a better quality. So we're reducing the amount of waste in materials and defects, which again, obviously going to improve the environmental impact. Transportation. If we're beginning to move to prefabricating in factory environments, perhaps we have less impact in terms of the logistics, the transportation of individual components to sites, whereas we can consolidate it down into a built element and deliver that to site. So again, we can take what the principles of other industries, of other methodologies, and start applying those to modern methods of construction, and beginning to tease out the aspects of improving the environmental impacts, and then which leads into what are modern methods of construction. As defined by the UK government, there's 7 categories of modern methods of construction, starting at category 1, which would be full volumetric modular, full built elements, and they can be either shell and core, or they can be fully fitted out with furniture and fixtures, right down to number 7, where we get innovative on-site processes leading to improvements. So it's not just one particular element. The key here is to look at all of the various aspects of modern method of construction and see how they play their part in regards to improving the environmental impact. A case study here from London, developer the Mace Group, looking at a very innovative modern method of construction and methodology of developing up a residential development, 525 4 apartments across 2 towers, and the anticipated result is a 70% reduction in construction waste and transportation, etc. And that's using modern methods of construction over and above the built traditionally. So we can see that by using modern methods of construction, we're reducing the waste by approximately 7%, 70% if that building was built by traditional means. So I think that the case studies here, it is proven that modern methods of construction do reduce waste. And again, another example for a project that's currently under construction in Croydon in London, full volumetric modular tower. It will be one of the tallest volumetric modular towers in Europe, and perhaps in the world once complete, 44 stories. A study carried out by the University of Cambridge looking at seeing approximately a 40 to 54% reduction across the 2 towers in embodied carbon. So again, it's looking at developing up the business case in terms of getting the quality, getting the productivity, improving, and then actually really targeting in on the embodied carbon and looking at the materials. You know, why is this building achieving such a reduced embodied carbon impact? Again, you can tease out in terms of the primary structure, less concrete, and more efficiency in terms of the materials, the lightweight approach to construction. So again, we can see here from a case study, it actually does work in terms of reduction in carbon. And again, if we talk about sustainability, it's not just about the carbon impacts. We look at ESG, environmental, social governance. We look at the social aspect of sustainability, and we can see from a health and safety point of view, you know, that modern methods of construction can really improve the health and safety aspect. You know, as an example here, again, going back to the case study by the Mace Group, products were used where we had a facade system connected to a floor plate lifted onto the building, so the leading edge of the building was fully protected. You can see by the image significantly reduced labor on the actual floor plates. So the risks are mitigated, the risks are reduced of health and safety impacts. And if we refer back that to the Irish construction industry, in 2019, we had 140% increase in fatalities in Ireland in the construction industry. The vast majority of those were falling from heights. So again, you know, we can then see the benefits from a social point of view to using modern methods of construction. So what are the drivers? How do we really push this on? Like, there've been lots of strategies, lots of national strategies that begin to tackle this. Here in Ireland, we have the Climate Action Plan, which begins to articulate the need for embodied carbon in new developments. And we can see that in London at the moment in terms of a very high profile developments being refused planning consent because they're demolishing existing buildings and building new buildings. So it goes back to the reuse and readaptability of the buildings. In Denmark are a world leader in this. They've now mandated the use of embodied carbon calculations within their building regulations, and using the circular economy and beginning to promote and tackling embodied carbon within the built environment through modern methods of construction. Which again leads me on to my last slide. The greatest danger in times of turbulence is not the turbulence, it's to act with yesterday's logic. So we're at a critical point in terms of addressing climate change, and we really need to look to more modern methods to address those. So I can take questions if necessary later. So I'll hand over to Ben.
Thanks, Pat. That's awesome. Let's move on now. Brian Kennedy is the managing director of Vision Built, a leading offsite manufacturing company based in the UK and Ireland. With over 16 years of experience in design and main contracting, Brian has a proven track record of delivering successful projects. He holds a Bachelor of Engineering degree from the National University of Ireland, Galway, and an MBA from Henley Business School. Brian has successfully completed projects in many sectors, such as pharmaceuticals, industrial, residential, retail, hospitality, and leisure. His passion for working collaboratively, utilizing lean processes and modern methods of construction combined with his embrace of innovative technologies ensures sustainable delivery.
Thank you, Ben, for the nice introduction. Look, it's great to be part of this. I think just before we go into a short video just on Vision Built and the business and what we're about, I think it's a really interesting, exciting time in the construction industry. As Pat mentioned, we have a number of burning platforms. Embodied carbon and our need for sustainable construction is a burning platform that's going to actually really accelerate the drive, and you can see it already from modern methods, because we have to change. And I suppose modern methods of construction has been around a while in various different forms going back many years, but I think it's different this time. I think we have a number of enablers like digitalization, we have the technology. I think we've burning platforms, which Pat mentioned, our need to drive down carbon. And I think a big element also is the change in our skill set. So our people and the traditional trades, the apprenticeships, they're not there anymore. So we have to innovate and come up with different ways to create built environments. And that's why it comes back to a factory environment. And I think that's why it's a really exciting time to be actually part of the construction industry, because that kind of flat line graph that has, or even decline on graph around efficiency in construction, I believe is about to change, and about to change quite drastically. And I think we as professionals in the industry can really make sure that it changes in the right direction, with quality always in mind, and driving that carbon. So the short video, and then I'll take some questions with Pat and the guys at the end. Thank you.
My name is Brian Kennedy. I'm Managing Director with Vision Built. We're here in the west coast of Ireland in Oranmore and Galway, which is our main head office. We've two factories as well, which are also based in the west of Ireland. One is in Sligo and one is in Mayo. So this is, I suppose, where Vision Built originated in Galway. We've recently moved factories and moved office to upgrade our facilities. And I suppose we supply here from all of Ireland nationally, and we also supply the UK from the west of Ireland. So quite an interesting company to have based in the west of Ireland in offsite manufacturing. So a lot of innovation, a lot of ingenuity around our product development, and we do maximise the amount of work we do in the factories offsite. Vision Built's base product is light gauge steel, so it's a highly flexible product, and it's used in our modular volumetric offsite solution. So basically we manufacture our own light gauge steel, we utilise that to form our volumetric solutions, and then that allows us to maximise, I suppose, the pre-manufactured value of our product. So basically we can maximise the amount of work that we do in the factories, taking away a lot of the risk from site into an environment which is highly controlled, highly regulated. My own role, I suppose, as Managing Director is overseeing the large amount of people that we have in our own business, so that right through from design, right through to procurement, operations, factory, and our aftercare team as well. So that can include between direct and indirect up to 200 people, you know, and this is spread across Ireland and the UK and various different projects. We operate in the education market, we operate in the housing market, and we also operate in the commercial market. Here in Vision Built, we predominantly are a modular volumetric, which is a Cat 1 product in terms of offsite MMC. So traditionally, we would have done a lot more of Category 2, which is 2D panelised light gauge steel. And what we found in the market is that, you know, our customers and ourselves in trying to continuously innovate and do more off-site, our volumetric offering allows that ability to do that. So while we get a lot of the fit-out trades, a lot of the finishing trades in the factory doing that work, which takes away the risk from site, we've also found that, you know, doing more work in a controlled environment, not dealing with weather issues, not dealing with site constraints, can greatly increase the quality of our product. So managing all them technical details air tightness details, getting the right U value, thermal bridge, managing all that quality of work is a lot easier and more controlled in an environment that's, I suppose, easier to work in. So our volumetric modular solution is a base product of light gauge steel. So first of all, that's panelised in our 2D facility, and so basically that panel then is used to form the box that creates the 3D environment for us to fit out to the roofing, cladding, windows install. All that follow-on works within this module, and the modules can range depending on product, depending on project. Whether it's a school, education building or a house, it can vary slightly in degree of finishes that we do in them buildings. So compared to traditional construction, off-site volumetric construction requires design, procurement up front. So one of the challenges is getting that information to allow design freeze, to allow us all to collaborate well together earlier in the project. So you're constantly de-risking the project, but once you go into the factory environment, you want to have all them details right up to your light location, your socket location, all that level of detail in the design that allows the manufacturing and the process to continue through the factory unimpeded. And I suppose that's one of the challenges we have in construction. It's changing that whole mindset to front load that activities and to understand and look at this. I suppose there's tools and digitization, virtual construction, AR, VR, all that can help us sort of visualize the finished building, get that design up front and allow design freeze and allow a very streamlined process after that. Predominantly our customer base is government bodies, Department of Education, housing sectors. Also we work with developers and some commercial clients and office buildings. So our process in our company, we do a lot of in-house design. We've kind of a hybrid model where we outsource some of the specialist consultants' work, including fire, structural at times as well. And I suppose that allows us to have flexibility to be able to scale up and scale down depending on our demands. Here in our head office in Galway is where most of our design department work. We predominantly use software such as the Autodesk suite of software, Revit, Navisworks. We also have some specialised software, Vertex, framing software that allows us to have a CAM process, an automated process right to the factory floor. So you'll see some of our framing machines that allow this process to happen through the Vertex software and digitally transcribed through into the framing machines, which then manufacture our steel exactly to that detail and that design in that model. So highly automated, highly efficient, very little waste process right from design to the factory floor. So a key tool we use right through our design and manufacturing process is our BIM modelling. So our designers model in a complete 3D world where we basically have a twin model of the building. These digital twins are utilised through our manufacturing sequencing, through our detailing. So a lot of this information is utilised to communicate from the design department to the factory floor. So all our production supervisors would be trained up in reading the BIM model, taking some dimensions off them, understanding how complex components go together, and this is all in that kind of virtual world where we can tease out issues. A lot of the process then is through a DFMA, a design for manufacture and assembly process. So I think one of the big changes from a construction project to more of a manufactured off-site product is the level of detail that we get into in our design. So we like to get to a place where every component is labelled, marked and kitted, and that component then has various different uses, but can be easily and efficiently put together in a way that everyone understands. So our manufacturing process starts with our raw material, which is typically coil steel. That's brought through our framing machines. So we've 5 different framing machines that swage, punch and roll at different depths, different thicknesses. That allows variety in our products. So whether it's a floor assembly, a wall assembly, a roof assembly, there might be various different build-ups needed. So while that product is then rolled through the framing machine, each of them components then is put together into a panelised product. So that panelised product is configured, typically screwed together, and that panel then is used in our 3D volumetric solution. So in the pre-assembly or sub-assembly part of it is we might apply our insulation, our boarding, etc. So the various different build-ups is done on a flat table, lifted into a vertical or horizontal, depending on floor, walls or roof, and put into a volumetric solution. Then allows all the follow-on trades to work in that environment. That's the process sort of from start to finish in the factory. So in terms of our capacity, we range from about 700 units to 1,000 units per annum. That can vary depending on what type of building we're doing, whether it's an education building or a housing building. So one of our largest customers is in the education sector. We do a lot of schools here nationally. One of the key advantages for offset manufacturing is the speed, and I suppose the quality of the product that you can get in the factories. The education department have a real challenge in terms of capacity nationally, particularly in primary schools. So what we can do is we can turn around buildings in quite a short period of time, especially when we've a kind of a standardised approach to the layouts of the buildings, the classrooms, typically what they want. And I suppose we've worked with the Department of Education in terms of getting them layouts standardised that suits modular construction, and then we're able to roll them out quite efficiently and at a high speed. Department of Education sector really requires a speed of build, but also a really high quality product that will last for centuries in terms of environments for kids and teachers to work in. So what our product offers is a very low U value, really high energy rating on the buildings, and this is down to the thermal bridging details and the products that we use in it. And I suppose the acoustics is a huge thing in schools. So how we detail our wall construction, floor construction, and all that side of it is really critical. So this is worked through standard details that we've rolled out and agreed with all parties. Also, I suppose from a fire rating, fire regulation is really important. Our projects range in terms of the requirements of view values, so we're quite flexible in terms of the view values that we can actually achieve, right down to 0.12, but typically our U values range from 0.15 up to 0.18, and I suppose this helps with the whole energy efficiency of the building. Similar to the U values, our air tightness of our buildings can get very low U values, below 1, but typically the requirements of education buildings, healthcare buildings is always around that 3 limit, so that's typically what our buildings meet. So the durations of our projects range depending on the complexity, etc. But just for an example, a large education building, 30,000 square foot, was done in less than 15 weeks. So this is a typical example, and that same type of project in a traditional process could take up to 18 months. I think one of the key challenges across, particularly in the education sector, is having a standardised approach to the buildings. So while we can introduce some bespoke elements to the buildings, we want to keep the core of the building, the most functional part of the building, very standardised. And this can be then rolled out at scale, so it increases efficiency, reduces costs, and overall performance of the building is greatly improved. In the education sector, being a father of 2 kids, quite passionate about kind of the spaces that we create for our future generations to get educated. So there's really interesting designs coming through in both modular construction, and it's interesting how these spaces are adaptable for various different needs. So while we're manufacturers by trade, we also think about what spaces we're creating for our future generation.
Thanks for that, Brian. That was excellent. So much covered. So before we, I suppose, move towards questions, we're happy to move over to Des O'Donnell. Des is a technical director at C&W O'Brien and will provide some insight from, I suppose, how adoption can happen, maybe from the developer's position. Des has 30 years of experience in the Irish and UK construction industry. He's been involved in a wide range of high quality design projects going back to 1995. In 2000, he joined Reddy ANU as an architectural technologist, was later promoted to technical director for several years before leaving in 2021. Des has recently joined the team at C&W O'Brien as technical director, bringing his extensive knowledge and experience to the new role. Throughout his career, he's managed teams on complex projects such as large-scale mixed-use developments, apartment schemes, student housing developments, through all stages of design to completion. In these projects, he has been involved in aspects of architectural design, project and team management, and has worked at senior management level for the last 13 years. He brings a wide range of experience and proven value to the projects he's involved in, and is ideally placed to give us this insight into the drivers for adoption of MMC methods at scale. Over to you, Des.
Yeah, just as Hugh says, thanks Hugh for that great insight there. So just in relation to the key drivers for adoption, so what we're looking at basically in this table here is it just shows the level of productivity and how low it is. The red line represents construction, say in comparison to the green and blue lines, which represent the information, communication, manufacturing industry. And it just shows that the challenges that we face in the construction sector, which come from a number of different factors, things like lack of skilled labor and inefficient processes, poor communication, lack of communication between the different parties involved in construction projects and delays, and etc. Economic conditions, economic downturns lead to demands for construction result in reduced productivity, government regulations and policies affecting compliance requirements, and lack of standardization in construction progress and increased costs. Technological gaps. The construction industry has been seeing new technologies which can lead to increased inefficiencies and the lack of transparency, environmental concerns, budget constraints. There's lots of constraints in relation to say budgets that limit the projects and have an impact and reduce productivity, safety concerns, and generally a lack of involvement of competent contractors in a project results in waste time, and they often designs are fully developed before realization of can be met. Like so you end up redesigning, retendering, and this results in a substandard product. And then what we're trying to do here is we're trying to look at the ways of improving productivity by, say, building commitment through strong core values, investing in lean principles, and utilizing technologies, training staff, and implementing innovative solutions to reduce resources and improve delivery. This shows basically that in the industry, and this is Irish and global construction sector, that there's lagging construction productivity costs the global economy 1.6 trillion a year. Now you can see there that the greatest losses are coming from likes of North America, Europe, and working their way down to the industries and the countries that have lower construction industries. But it's like 1.63 trillion loss due to the productivity issues. So that's a huge say challenge to try and increase that. We need to look at R&D to increase productivity, particularly in the Irish sector, and we need to look at improving basically productivity by being able to look at cost savings, faster completion of projects, and to realize this in the competitiveness in the global market. Pat sort of touched on these earlier. These are the 7 categories of MMC, and going from 1 to 7, basically showing the 3D primary structural systems down to number 7, which is the use of the different technologies to enhance the construction. This is basically again, Pat touched on this earlier as well, but using different technologies here, like not just one form of MMC, but like structural frame, precast concrete, bathroom pods, service modules, implementations of digital platforms, and this jump sequence where they actually can construct things and sort of work sort of on one level, and then you're preparing and setting things up for the next level, and you work up through the buildings, and this really improves and increases the productivity in the systems. So that therefore gives you reduced construction times, improved quality control, cost savings, increased design flexibility, safety, and increased sustainability, and using the use of technology. That also then leads itself to higher quality buildings. So you end up with basically greater precision, increased durability, greater energy efficiency, and design flexibilities in this. So again, this is another example just showing how this can actually improve the benefits. So they reduce on-site labor by a lot of there's fewer accidents and injuries on the construction site, improving working conditions for the people, because a lot of work is done in the factories, increasing safety so that you have safety in use, where you have more durable and a longer lifespan for the prefabricated elements that are assembled on site, improving air quality for buildings with better indoor air quality by using prefabricated components that are made from sustainable materials, greater design flexibility to allow for better geometric shapes and forms to be created, and innovative building designs that take into account the well-being of the occupants. And then basically by using MMC techniques which enhance the sort of design, fabrication, assembly, add greater precision and accuracy in the final product, and therefore you have a smarter and better built buildings. The 3 pillars of sustainable development are economical, environmental and social sustainability. Social sustainability then promotes social justice and well-being, improves working conditions for factory workers, reduces on-site labour, creates buildings that promote health and well-being. An example using prefabrication and modular construction. Environmental sustainability maintains ecological balance, preserves natural resources for future generations, reduces waste, uses sustainable materials, incorporates energy efficient features. Economic sustainability, that meets the needs of the present without compromising future generations, reducing construction costs, increases productivity and innovation, and supports local economy through the use of local materials. So, why has the adoption of MMC at scale in the housing sector failed? So there's a number of reasons, I suppose, in relation to this, in terms of lack of awareness and understanding among the different stakeholders in the housing sector, developers, builders, and the consumers. Limited availability of the skilled labour, high initial cost of MMC, the cost of equipment and machinery compared to traditional construction methods, limited supply chain, products and materials can be difficult to get the materials needed for these projects, and then some regulatory and planning barriers. So what we need to do is we need to look at increasing awareness and education among the different stakeholders, show them the benefits and the potentials of the MMC, developing a skilled labour force to be able to work on the projects, and try to look at reducing the initial costs of MMC and the cost of equipment and machinery needed, and then to develop a robust supply chain for the MMC products and components, and then look at addressing the regulatory barriers that are currently in place that make it difficult to implement MMC techniques for codes and regulations. This is indicating basically a comparison between the RAI work stages, which is basically the stages from inception of 0 for a project up to 8 when the project's finished on site and it's handed over. And it shows there that the benefits of MMC really matter at the initial inception stage. That's when you see the greatest benefits. And as you can see, as the project develops from inception down to the end, the benefits are lessened. So the advantages really is to try and implement it, MMC at the earliest possible stage, to look at basically enhancing and delivering the savings on the actual development. So this is looking at basically how DFMA, design for manufacturing assembly, can enhance the use of in a construction process. So the first part of the slide there, which is pre-project, showing that is critical that we look at the strategic definition of the project to implement the use of MMC technology in at the earliest possible stage. That's when you see the best benefits, and then you look at basically building a business case to include for the aspirations, for the strategy, for the digital delivery, and if necessary, appoint an MMC sort of specialist to actually to work with the stakeholders on that. And then looking at this basically at the various stages, the best way of enhancing this productivity and getting realized solutions here is to actually look at it from the earliest stage, design, cost deliverables, MMC options, and basically doing different options at the earliest stage all the way through to tender and procurement and then adopting it. The key benefits for the design is basically increased efficiency in the design process, improved constructability, reduced waste, enhanced collaboration, improved quality control, and the better integration of building information modeling that can also help to make this enhance the system. Greater flexibility and adaptability to allow for the manufacture modular prefabricated components that are easier to adapt to changing project requirements, and then enhance sustainability to promote the use of sustainable materials and methods, resulting in lower carbon emissions and greater resource efficiency. Different stages, again, this is just showing that you have different, in a typical, say, apartment situation, you have different systems, like, so for instance, things like bathroom pods, kitchen pods, wardrobes, and they can be used, and during the design stage that these are all implemented into it. So the actual the benefits can be seen by having mass production of modularization will add speed and quality and all the issues that we went through earlier there. This one here is just looking at the potential of basically introducing materials, like, so in this case, this is a product called Carbon Cure, which is a particular concrete that's used, it's used to basically to reduce the embodied carbon for ready-mix concrete. So you have the 2-story high prefabricated precast columns, and in the introduction, which in itself adds to the speed and the form of delivery. But the actual product itself, which is the largest carbon elements, are the cement, which is 58%. By pumping CO2 into the process of the construction of the concrete, this reduces the actual embodied carbon, and thereby you seeing the double benefit of actually the speed of erection and the quality and the enhanced sustainability of the actual the end result. And that's it then. So just to say that the use of modern methods of construction is crucial for the construction industry to meet the challenges of sustainability, resilience, and affordability. Thank you. That's it on.
Thank you, Des. That's great. And yeah, I think we can all see the benefits of modern methods of construction in terms of health and safety and speed and all these things you've highlighted. I think one part of the presentation early on that strikes me, it's always interesting in the car manufacturing world, how you showed the image of lots of robots creating the cars, but yet that never seems to be the case. Or certainly with the factories that I have been to, it's always people who are still doing the work within the factories. And we've seen quite a bit of concrete and steel. I feel out of my depth in terms of virtually all the construction that I see with housing is very much done on site. But yeah, I am talking probably small scale and self-build, whereas you've covered a lot of much bigger buildings. But it would be interesting to know if there's any reason the light gauge steel, for example, is being pushed in a big way, whether there's a structural element to this. What do you think, Hugh?
Yeah, thanks, Ben. Yeah, I've got a few thoughts, I guess, and maybe like you from Pat's slide, the one that jumps out is I suppose the MACE project references, where we've got 70% reduction in construction waste and 50% reduction in embodied carbon. And while that's incredibly compelling, I'm then kind of worried about where's the driver for it, and the reference for, I suppose, the importance of mandated embodied carbon regulations that control that. And I think kind of ultimately that could be the big driver for a lot of what we're talking about. And it's really something that's missing. broadly speaking, kind of overall, you know, that while we can build these factories and there's, you know, incredible work that can be done for scale, it may need that regulatory approach to actually kind of force people to make those moves. And I was looking at a couple of questions, I guess, and you've got this kind of huge buzz right now around MMC and modern methods of construction, and lots of different companies are investing lots of money in factories all over the world. And I suspect there's people on the, you know, in the chat here that have some strong opinions on that. Some of those factories have failed, and for different reasons in different places. But yeah, kind of I'm wondering, and maybe Brian, you could be a good person to jump in here, but are the factors, you know, kind of without this mandated carbon reduction, you know, as part of the regulations brought in, are the factors of safety, speed, CO2 reduction, productivity, or bridging the labor gap, are they enough to maintain the investment that's going into the offsite industry overall? You know, is the pipeline strong enough, or do you see the pipeline growing actually to, you know, to sustain that?
Yeah, look, it's probably the most interesting topic, because there has been some pretty major failures in large factories, particularly in the UK, over the last probably 12 months, you know, and when you really analyze what was the reason, and you mentioned some of them there, but I think a big one is the lack of standardization. So when you think about all the great buildings we build, they're actually all kind of a bespoke kind of prototype when you think about it, you know, the first of one, and then you go on to a different design. So that really doesn't work in mass production. And while we want to keep our architecture unique, we have to focus on kind of the functional buildings and the core of the buildings as really standard. And once we standardize that design, our factories are set up. If you go the opposite way and try and set up a factory for, you know, various different designs and all that, you need to build in huge agility, and that doesn't work in mass production. Your cost base will always be high. So I think one of the keys is trying to standardize your base design, have the add-on customization that can create magnificent looking buildings, but what's behind that, the structure, the skeleton, all of that, fire detail and all of that is kind of a very much standardized approach that's agreed across the board. And I think that's going to be a game changer. And I can see that happening, Hugh, in some of the, particularly around government bodies, they're starting to realize that, you know, we can't have various different designs in different places, you know.
Yeah, it's a good answer, Brian, and pretty much was my next question as well. I was kind of getting into actually. I've spoken to people setting up factories, and they're kind of that opinion that it just doesn't fit to create the factory to build, you know, what people are getting permits for or planning regulations for, that it just doesn't match. You know, the things need to be really designed from back then. And I guess that's kind of the next question I was going to ask, and it could be of you or Pat, maybe even from the UK side of things, kind of what's happening in that space, you know, to support the FMA. Is there, you know, do we see changes in, I know Part B or for fire is due to change in Ireland soon, and you know that has potential to, you know, bring in some improvements for MMC, but you know, from a planning point of view, that seems to be huge, and really maybe the biggest problem, you know, for how we can build sustainably using offsite construction.
Sure, if I could come in there, Hugh. I think if we look at, I suppose, multiple points made there by Brian also. I think in my view, it's one of the biggest barriers actually to the adoption of higher rates of MMC. And I see in the chat the question in relation to, whilst we see high levels of MMC, it's not really impacting on the overall cost of projects at the moment. But I think if we look at the maturity levels of using the various categories of MMC in projects, certainly it's not at that level where it is beginning to really influence in terms of productivity and cost. And as we get into more pre-manufactured value on sites, I think that will change. I think in terms of certainly factories and the driver for mass standardization, the construction industry is significantly defragmented. You know, we're procuring, particularly here in Ireland at governmental level, we're procuring projects on a project by project basis. So to get that impetus to develop up and invest at factory level to start producing, volumetric modular, I think it's incredibly difficult, and I'm sure Brian would have certain thoughts on that. So I think at governmental level, we need to look at centralized approach, but that actually has its challenges also in the UK, as Brian alluded to, in terms of some major manufacturers shutting down last year and ceasing production. Even though the UK government have policies where they're linking low carbon construction policies to MMC policies with significant investment in framework. So I think that there's something that we really need to review and zone in. And one final point in terms of DFMA, at the end of last year, I co-authored the Royal Institute of Architects DFMA overlay approach to design that Des alluded to. So it's getting that mindset to integrating early adoption of construction process, understanding the impacts of construction, standardization. If we relate a built asset to perhaps the automotive industry, there's a lot of standardized components in the automotive industry that can swap and change. They're not unique. Certain aspects of cars are unique and different brands, but when you get under the bonnet, there's multiple elements that are standardized. So if going back to Brian's point, we need to move to standardization, perhaps move to a platform-based approach in terms of that centralized procurement, where we have standardized platforms of kits of parts where we can start pulling from, and then that begins to create the economies of scale to really address the issues within the industry.
Yeah, I think that standardization point is a really important one, isn't it? And I know we've had questions in as well, retrofit. So I think that we ought to check in with Zach.
Great. Yeah, thank you, everybody. And we do have a number of questions, and we know that the presenters have graciously agreed to stay another 15 minutes. So I recognize, though, that it's the top of the hour. So if you need to move, folks in the audience, if you need to move on to the next part of your life today, we totally understand. That said, I think we'll roll into this bonus 15 minutes here with some questions. The first, and I just shared the queue for questions in the chat, but the first question comes from, and I'm sorry, I should know this by now, but is it Gal or Gail Spanier?
It's Gal. You got it right the first time.
All right, thanks. Great. Thanks, Gal. It's good to see you.
Thanks a lot to the presenters, and I'll maybe reframe my questions a little bit since a lot have been talked. But basically, what I see in the US is that between volumetric and panelised, it's almost a cap thing. You either define yourself as one or the other. And when Brian was speaking, I'm trying to think if it's possible to look at like panelised as something that either feeds the volumetric or goes out to the site to feed like an on-site panelised building or even an existing building, or are like sort of like the nature of volumetric too different? And so happy to hear any of the presenters' opinion on that.
Yeah, I can take that if so. It's been so Gal, yeah, no, great question. And I suppose us being a manufacturer originally of panelised, it was kind of natural flow that we fed then, as you said, the 3D factory off that 2D panelised line. The only difference really is in your build-ups and that. So you can absolutely use your panelised line to feed the external world, if you like, but your build-ups and your efficiency might reduce. So while it can be done, it's not ideal. And we've probably developed into nearly fully Cat 1 business. Our panelised actually external isn't our main product at all. It just feeds our 3D assembly, but it can still feed externally. And look, at some developments still suit a Cat 2, absolutely. And we can still do that, but it's not the most efficient. Sometimes you're better going with one,
Great, thank you, Gal. All right, next up is Philip Jordan.
Well, hello, thank you very much. I was simply concerned and remain concerned about the lack of retrofit focus certainly in the UK, and I don't know what it's like in America or other countries, but we just don't have much of a retrofit initiative going on, and it needs. We've only got, according to the IPCC last April, we've only got basically another 2 years to begin to reduce emissions. They're currently still going up, and they mustn't and they can't, but we won't get to the 1.5 lifestyle if we carry on at the rate we're going. And we certainly won't do it if we just focus on new build being efficient, because in the UK we only have around about 1/3 of a million new homes a year if we're lucky, that's just historic. Whereas we've got 29 million existing homes according to the Climate Change Committee, and around 2 million non-domestic buildings existing, and almost all are way out of line with the standards that we need to have in retrofit. That's my statement of fact. It's great to see modern methods of construction, but it's not really relevant, is it? I know energy sprung, etc. exists, but where's the link to what we should be doing?
If I could come in there, it's Pat. I think it actually, perhaps I could talk in the context of the Irish government's approach to energy retrofitting. I think we're certainly addressing it at high level. We're promoting major funding for householders to engage in deep energy retrofitting. I think the issue is that we're not carrying out deep energy retrofitting at scale. So at the moment here in Ireland in particular, it's individual. So it's up to the individual house owner to engage with a contractor to perhaps, upgrade their home. So we need to be doing it at mass. We need to be doing it at scale. We need to articulate better the benefits of deep energy retrofitting. If you're saying, okay, energy costs are significantly rising, we're putting forward the business case, it's going to cost X, Y, and Z in terms of to get that. Where are the benefits? What's the payback? What does it actually mean to the house owner to do that? And I think that's something that we, as a nation, or as a certain policy adoption, we need to start articulating better. Certainly, from an MMC point of view, I think Brian shared some fantastic examples, of how we might go about doing that. And I think there, if we start looking at modern methods of construction as a means to address deep energy retrofitting, it's not going to be addressed until we get the economies of scale. So if we can start getting mass adoption, mass energy retrofitting at development scale, I think then we'll begin to really see the benefits of particularly modern methods of construction as a means to achieve the deep energy retrofitting, if that makes sense.
Yes, it makes sense. The RIBA has issued a statement along with, is it called the UK Building Council? They're both saying we should approach this on a wartime basis, which is rather an echo of what somebody in Canada did a year or so ago. I saw something that said we should be doing what was done in the Second World War, and they showed what Canada had done in the Second World War. And there's a video link to both that I've got, and that I've circulated quite a lot, but nobody's really following it up, I'm afraid, because unless you do approach things in that sort of scale, you're not going to achieve what people know is necessary. I just draw it to people's attention.
I think just from a manufacturer point of view, Philip, you're dead right. Like even in Ireland, like the numbers are, we're only in the low percentage of what should be retrofitted, like a couple of percent. It's crazy when you look at the numbers, and it's the exact same in Ireland. So I just sent a link on the Drive Zero R&D project that's just complete in the Midlands in Ireland, where we actually panelised the retrofit around a semi-D, really interesting. Then we've done a Cat 1 product as a porch on the front. So there is, you know, it can be done, and it has to be done at scale, as Pat said. You know, it cannot be done in a fragmented process. But
well, there's Energy Strong and there's BT Passive or something, that, but it is, there's several different systems around, but you need to, as you say, you need to apply them at scale. Anyway, that's perhaps blowing the main thing of today's talk off course.
No, it's absolutely central to the project, Philip. Thank you very much for your comments and your question. Okay, so up next is Jeff Colley. Jeff, thank you for joining us today.
Hi, Zachary. I'll keep my video off because I've got dodgy internet here.
Yep.
And hopefully it'll hold up for this. No, thank you. Some very interesting presentations. I just put forward a question about. I suppose I have concerns about the usefulness of the term MMC, because it's a catch-all term that doesn't really necessarily say very much about what is and isn't, you know, what the boundaries are, about what kinds of systems you include and exclude. We published in the magazine, panelised Plus magazine, a couple of issues ago, an analysis. The headline referenced the mockumentary Spinal Tap. It's called Up to 11 was the name of the article, because you run out of headlines after a while when you're publishing a magazine, you know. It was we had 11 different build systems included, and it was a reference to the guitar player who wanted an amplifier that went up to 11 rather than 10, so it would go louder. But anyway, the point was that we looked at different build systems, compared to including a number of MMC systems, and compared them to traditional construction. And it was very clear when we did embodied carbon calculations for the different build systems that some MMCs were way better than traditional construction, and some were in fact worse. So I just find, you know, I think there are some, I suppose, benefits to MMC that are kind of nearly universal to MMC. But the idea of ascribing particular sustainability benefits in particular to MMC generically, I struggle with, frankly. You know, I wonder if anyone has any comments on that, on its usefulness as a term.
Hi, Jeff. Pat here, Kirwan. I think if you begin to look at individual MMC categories, and you compare one category to another, and you're comparing, you know, are you comparing apples to apples, etc. So the key is actually, it's looking at it at a more holistic level in terms of the overall built asset. What I think Des had a fantastic slide where you begin to look at the materials used to incorporated in the certain category of MMC. Where you're looking at concrete, say, for example, and you're saying, okay, you know, what is the embodied energy calculation of concrete? How do I reduce that? And then also integrating that within the form of, say, precast, for example. So now you're beginning to not fully address embodied carbon, but you're beginning to look at how might I go about reducing embodied carbon within this certain form of MMC. And then if you take that on a larger scale within the overall built asset, you can then look at, you know, what does it mean? And this is where, particularly in terms of a DFMA approach, and I'm sure you're familiar with the RII DFMA overlay that we launched late last year, where we begin to look at MMC optioneering at an early stage. And a key part of that is looking at the environmental issues, looking at the embodied carbon, looking at any other elements such as air tightness, or whatever it may be in terms of the overall energy performance of the building, and coming up with a strategy to address those, and not just eluding and not just zoning in on one particular aspect or one particular category of MMC, but looking at it at a more holistic level. And of course, you're going to get different, you know, even if you look at full volumetric modular, where you get a steel frame or whatever it may be, the embodied carbon and the issues of one volumetric modular unit from one country will be different to a different country, because you need to look at obviously the energy mix that's being used to manufacture the components, etc. So I think that there's a lot there, But I think in summary, in my view, the key is to look at it at a more holistic level, not just zone in on any one particular MMC category, but see how all of those categories may together combined to address the environmental aspects of the built asset.
Thanks very much. Yeah, it's very interesting. It's a struggle. I have to say the point that Hugh made before about, you know, just setting embodied carbon targets. If you're looking at that one subject, for instance, regulating it, that for me, I think is the solution. And you know, and I'm sure that MMC systems, that and the thinking that comes with it, it's possible to achieve greater improvements, perhaps, you know, with many MMC systems than it will be with a lot of traditional construction. But I just fear people's, myself included, tendency to kind of oversimplify things and look for, you know, it's very, I can just see people procuring and saying, oh, sure, we'll put in an MMC, you know, we'll go to tender from an MMC and that'll be our sustainability covered, you know, rather than actually setting enough specific, robust, stringent sustainability requirements to keep them honest, you know.
I would agree, and actually it really shows the importance of building the awareness and the knowledge aspect in terms of educating. You know, you're doing a fantastic job in Pacifiers Plus, and you know, it's you know, articles and publications and building the case studies so that we can build up that knowledge as an industry. And it's certainly not just taking, okay, I'm using an MMC category or building, and this is my tick box to a better sustainable asset. So I think there's multi-layers, I think, in this, but I guess we have to start someplace. We need to start moving from a sustainability point of view, but we also need to build that knowledge and skills to achieve it.
I agree, Pat, and Jeff, just on it from manufacturing point of view, you know, the build up. So actually even just measuring our buildings, that's the first step. And I think we're doing there's a lot of talk in the industry, but we actually have to start measuring. So just one of the things, we're creating a tool that will just measure all the various different build ups. And then, as Pat said, you can optioneer as you develop, you know, even from the groundworks, what type of foundations you use, and you have various different options of various different embodied carbon. So I think the measurement is the first step, knowing the various different options, and then setting them targets is going to what has to drive it.
Thank you. Excellent and provocative comments and slash question there, and really insightful answers. So we have one more question. If you have a question brewing in your mind, please pose it in chat. Otherwise, we'll start to wrap things up. But our final question at this point comes from Diarmid Cronin, and my apologies for probably butchering your first name. I'll go ahead and ask the question on your behalf. So is BIM for all design teams members using MMC an absolute must? So is BIM an absolute must? Any comment on the embodied carbon of the steel frame / extruded aluminum element versus the alternative? So there are a number of questions here. How vertical and horizontal, how are vertical and horizontal fire cavity barriers dealt with? And maybe we keep it to that. So is BIM an absolute must? Comments on embodied carbon around steel frame and extruded aluminum element, and vertical and horizontal cavity barriers.
Yeah, if I can start. So from our side, I feel BIM is a must. You know, it can be done from, you know, from a kind of a 2D environment, but it's highly inefficient and highly inaccurate. So yes, to drive MMC, BIM is a must from our side. And I might just shoot down the carbon one, because we deal a lot in steel, and I think, you know, while steel might have higher carbon in the raw manufacturing, it has quite a high recycle content. So the circularity of steel is where we need to be starting to really think about it. And we're creating assets that can be used in the future. And this is where Pat mentioned about component-based, platform-led designs, that you actually own assets that can be reused. And I see a lot of companies actually starting to recycle steel members and that. So that's real positive for the steel industry. And the final piece then, vertical horizontal fire cavity barriers. That is absolutely key, particularly to modular construction and control of voids, understanding where voids are. So this is done, first of all, your fire test, your baseline, and having the correct fire test, and then control, and so priority boarding, the way you wrap the main structure. And so we always talk about dealing with the main structure first, and then looking at how you deal with the vertical and horizontal barriers. So if there is any voids, they need to be dealt with traditional type materials, but placed in the factory. And the final comment, on-site testing, so off-site testing certification for fire. So I think, you know, it's a big challenge in the industry at the minute. Every business, including ourselves, is spending a huge amount of money in testing, and there's not enough knowledge sharing. So I think what has to happen in the industry, and I know MMC Ireland and what Pat is leading on their side, is trying to get more collaboration, more sharing of information, and I think that's going to really help the industry, because at the minute there's very disjointed and everyone's doing their own tests, holding that IP. But I think sharing that will actually benefit the industry as a whole. And particularly, you know, the lack of fire test houses is a challenge as well, and timing for fire tests can be quite a long lead time.
Sorry, just to come in on one, it's Pat here, just to come in on one point that Brian made in regards to fire testing, and you know, particularly we need to look at it at an overall build-up approach, and not just individual MMC components or elements. Particularly if you look at volumetric modular, you have a volumetric modular unit perhaps with an external facade skin. So what is the impact of the external facade skin perhaps on the volumetric modular unit? So it is a complex area where we need to begin to look at whole system build-ups in terms of performance testing, and not just rely on individual components.
Fantastic, thanks, Pat. We have one last question. I think we can probably squeeze this one in, and then we will need to wrap up. So Patrick 2, can you ask away?
Hi Zach.
Hey Patrick.
Yeah, I was just wondering about you know, livability considerations when you look at Brian's reply to Hugh on standardized core design. I mean, a happy building, happy occupant is a happy building, and a happy building is a happy occupant in reverse. So is there any consideration in the MMC process for you know, recreation and livability and those type of concerns? Because we see invariably looking at you know, social housing and the monotony of some social housing in the past, that how it has created such trouble for, you know, harmonious living in a new build. So I just wonder, is that catered for by the MMC process at all, or is it a design element?
I take it, sorry, it's Pat here, I take that also. I guess coming from a designer's point of view, and I see where you're alluding to in terms of having identikit buildings, you know, yeah. If we start mass producing buildings, are we going to get building after building after building the same? And you know, what is the quality of life for the building occupants? And I think that's what I was alluding to there in terms of a platform approach. Whereas if we can look at standardization, but with mass customization, now you may seem that's a contradict. But if we look at, you know, what are the standardized components that we can build within an overall built asset, and then take those standardized components and use them perhaps, you know, in a way where we're beginning to articulate the architecture of the different built environments, and then we can really then see, you know, the last thing we want to do in terms of identikit buildings and really push on the design. In terms of the quality of life is not just obviously the design of the built asset, but it's also, you know, the indoor air quality. You know, what does it mean in terms of the materials that we're using within the various MMC components? So that's something that we can look at through the the development of MMC. But certainly, as to summary, the answer to the question, I think if we look at it on a standard, a component level, and then we say, okay, how can we standardize the main components to really then begin to deliver that customization so that we can really deliver a high quality built environment from a design point of view.
Thanks, Pat. Pretty comprehensive reply there, and covers a couple of my concerns. Thanks very much.
And I think just from a manufacturing point of view, again, I think I agree with Pat. You know, there's the main parts of the build, the main structure, the main details that we look at, platform-led approach, standardizing them, and then having customizable, whether it's facades, and just building in flexibility even, you know, in some of the layouts. So while we use kind of hot rolled steel frame, it creates flexibility in the future that internal walls can be moved, or if there's adaptability, so you can actually build in that flexibility in the future as well. So it's about thinking about it up front, I think, is the key.
All right, well, I think that does it. So I'll throw it to Ben and Hugh for some closing comments.
Yeah, I don't think I have much more to add. Very interesting. Clearly, lots of scope for expansion. I guess my point is really just keep measuring, making sure the embodied carbon and also the operational LNG really is like that on site. And yeah, I think there's plenty of scope here, isn't there? What do you think, Hugh?
Yeah, I guess look, as always, a big thanks to Brian, Pat, and Des for the open sharing of info and allowing everyone to ask them lots of questions. Same to Michelle, Uli, and Dara for all the work in the background, and to Zach and Kim. But I think we always get back to embodied carbon in these chats. So yeah, we may have to change the name. But you know, it's really interesting. It's a key topic, and we're going to hear a lot more about it this year. I think it was kind of, in a way, progress in that direction was derailed with COVID, and you can see it really coming back to the forefront of everyone's mind again. So it's important and good that we can have that discussion.
Great. Thank you, Hugh. Thank you, Ben. Thanks everybody for being here, and great presentations. We will be back again next month, so please stay tuned and enjoy the rest of your Thursday.